Hello everyone, thank you very much for taking the time to watch this Logic World video that I made today for November 8th, 2021. And this is my freshman attempt at making something fairly complex and functionally useful as opposed to my previous Logic World videos where I was just testing and goofing around with the components. And for my little self-imposed project, what I wanted to do is to make a billboard. And at first glance, some of you might say, well, gee, a billboard is really not that difficult to make. It's simply a matter of assigning pixels manually at certain locations on the billboard, as shown here. But you're only seeing the end result of it. What I have done is, first of all, create a crude addressing system using a series of switches in order for me to specifically set a character at a row and column at this on this board. And in order for me to do this, I had to create a storage system that stores 23 columns and 4 rows of character information in the form of a 25 pixel matrix. And if I were to jump up now and show you, this is not the end result. There's certainly a lot happening behind the scenes. And as you can see right here, I created a series of boxes that use delatch switches to store pixel locations for every black square that you see on the screen below. So I'm going to move forward and first of all show you where the characters are being set and how this crude addressing system using switches works. Now, as you can see here, each column represents a stack of 4 characters, and I can set a plotted character using these series of switches here. Now, as to which row it goes to, and I'm going to turn on the interface in order for this to work, I can say, well, I could turn on all or one of these switches to paint a character plotted here onto the screen on the opposite side of this structure. And I'll give you an example. I'm going to paint or plot a character on the second row of the first column. And as you see here, oops, I actually got that done backwards. I guess it kind of helps to label things, am I right? There we go. There. So when you have the switch down, you're basically telling the storage modules here that this particular row at that particular column, I want to plot and store a shape. So I'm going to create a question mark. And yes, switches are really a terrible way to plot a character, but the problem is I tried using buttons, and buttons do not hold an on-off state. You press it, a value is on, you release it, a value is off, and that was not constructive to what I was trying to do. So I had to use switches in order for this to work. Okay, so I have successfully made a question mark. If I were to warp to the front of the display, you will see at the first column on the second row a question mark. Oops. And there you go, because this was not there before. Now the interesting thing about plotting is that I have to be very careful when I'm plotting the image not to create a reverse image or mirror effect version of the character I plotted. I actually have to twist the image around as it's being plotted so it is not in reverse. That is, the question mark being backward, like of something out of a Bizarro universe in DC Comics at this location. So exactly how is this information stored? Well, I'm going to warp to where the storage modules are. And if you look here, each square is assigned to a storage module, which is from here to here, and each storage module contains 25 pixels or 5 by 5 matrix. So I have here, if you look very closely inside, 25 D-latch subs that store the state at a particular location on this grid, either an on or off value. Now, if you remember the 4 switches from the control panel, the control panel, the 4 switches that you saw on the control panel indicate whether to store or not store at a particular location. So I have the wires running to converge here along the bottom of each D-latch switch. And when it is on, I can start plotting a picture on here, and through this rather messy tangle of wires, which not only shows just how much I need to learn how to place circuit wiring down, it also shows how I'm turning the image or reversing the image around so that when I plot something on the screen at the console, it doesn't appear, as I said before, as a mirror or reverse image. This actually twists around the image 180 degrees so that it plots correctly on this display here. Now you're kind of noticing that these pins are lit, but these pins are not. And the reason why is because when I plotted a value below, which just happens to be, I think, the letter F on, it would help if I held down the shift key. I can move so much faster. Or teleport. I wanted to basically, actually I decided to make this a blank. Because I wanted some centering on the billboard. So you'll notice that because it's black here, even though there's actually an image being painted on the opposite side, because I have these the store pin with no signal as shown here, it's not going to store an image no matter what I store here. It will not get stored in this value. So you can kind of treat this 25 array of D-latch switches as some sort of well, let's just call it an array. It's a binary array that contains a state of 1 or 0 values. So to go through each and every one of these things, there are 23 different displays for each, going all the way through that are then stored in columns and banks of storage, reversed and then finally manifesting itself as a coherent display on the screen below. So, like I said, a fairly complex bit of work for my freshman attempt. I'm really proud of how it turned out, and my sentiments pretty much mirror what's displayed on the billboard here. Definitely Jimmy, Felipe, and the rest at Mouse Hat Games. You guys created an absolutely wonderful Sandbox toy. I really enjoyed working on this sign as my first self-imposed project. I started this project on October 28th, 2021, and I just finished, I think I finished on November 6th or November 7th. So it took me about just a little over a week on and off, 2 or 3 hours a day to work on this, and also writing things down on a piece of paper. So yeah, Jimmy, Felipe, and the rest of the boys and girls at Mouse Hat Games, you guys created an absolute Steam offering winner. I hope nothing but the best for this success of this game. I don't think it's going to have any problems finding that success. It's certainly a very enjoyable toy to play with. It also teaches you some of the basic fundamentals of logic circuit design, and it can be done for anybody at any age, people who are young children or who are maybe in the middle of some kind of career transition and want to get into logic circuit design as a precursor to electronics. But anyways, that's pretty much it. Thank you very much for taking the time for watching this video, and bye for now.